So hello, we're doing good and welcome back to my channel. Today we are at day 24 of the May Daily Leetcode challenge, and we have again a medium level question in front of us. And as you might be knowing by now, it's again a question on heap, and from the last few days we are having a question on heap. Let us see what the question is. Okay. So yeah, it's question 2542, maximum subsequence score. Okay. So we are getting this technical word subsequence. Okay. So I hope you understand the difference between a sub array and subsequence, and we will see that now. But I will just request you to, if you can just Google once, what is the difference between sub array and subsequence, if you're new to this. Okay. And coming to today's solution, what we are given is, first see the input. We are given two integer arrays, okay, and a variable k, which is also integer. Okay. So just remember these things and let us see the question. Okay. So what we are doing is, we are given two zero index integers nums1 and nums2 of equal length. This is important. Their length is equal and a positive integer k. Okay, you must choose a subsequence of indices of. So what we are to do is, see, let me tell you this very briefly. Okay, you need to select k elements from this. Okay, any k elements to select here. Okay, let us say I'm selecting 3, 3 and 2. Okay, so come to the corresponding elements in the nums2 array. Okay, it becomes 1, 3 and 4. Right, what we are doing is, take the sum of these three. Okay, then take the minimum of among these three, multiply the two. Okay, you will get some answer. Okay, we have to find the maximum possible of such answers. Okay, that is the basic idea. Let us see how they have mentioned it in the question in technical terms. So see, we are basically selecting k integers. Okay, yeah, k integers from nums1. Okay, nums1, we are selecting k integers. The sum of the selected element from nums1 multiplied with the minimum of the selected elements from nums2. Okay, what it means is, see, again, let us see, they have given some examples here. Suppose we are considering indexes 0, 1 and 2. Okay, so what are the elements 0, 1 and 2? 1, 3 and 3. Okay, what is their sum? Their sum is going to be 1 plus 3 plus 3. Okay, which is going to be 7. Okay, now come to the same indexes in nums2. Okay, now what is min among them? Okay, the minimum is going to be 1. Okay, so this is 7 and this is 1. Okay, this is 1. So 7 into 1 is 7. So 7 is just a one, just a answer. Okay, we have to select the maximum also possible answers. Okay, they are calling it as a score. Okay, that is the technical term they're using here. That's fine. So 7 is a score, and we have to find all such possible scores. Then we have to select the maximum among them. Okay, similar, they've given example here, indexes 0, 2 and 3. Okay, just check for yourself what are the values in those indexes in nums1. Okay, they are 1, 3 and 2. Okay, and in nums2 the values are 2, 3 and 4. Okay, and that's what they're doing here. They're taking their sum from, see, these are the elements in these indices in nums1. Okay, I'm taking their sum here. Okay, just let me take some. So 0, 2 and 3. Okay, this is 0. Okay, this is 2, and so this is 2 and 3. Okay, so 1 plus 3 plus 2, which is going to be 6. Okay, 6 into the minimum of 0, 2 and 3. That means 2 and 3, for the minimum is 2. Okay, so 6 into 2 is going to be 12. That's what they are mentioning here. Okay, so I have to find a way to, like, for all such possible indexes. That means for, see, that's why they're saying subsequence. Okay, that's why they have used of subsequence. Means, see, they've given definition also. Subsequence of indices of an array is a set of derived, that can be derived from 0 to n. That means, select any k integers, any k. They need not be together connected, something like that. Okay, any k. For example, 0, 1, and then some other indices. You need not take them continuously. Okay, for example, 0, 1 and 2, you need not take like that. You can take 0, 2, 5, 9, something like any index you can take within the limit of this array. Okay, then you have to repeat this process. What is the procedure? Take the, see, select those indices. Okay, the value in these indices found in nums1, you have to take the sum of them. You have to take the minimum of the elements found in those indices in nums2. Okay, then you have to multiply the two and get the answer. Okay, let me tell you one thing, k is going to be fixed. Okay, k is 3 in this case, k will vary in every case. Okay, that is the basic idea. And you can see here n is in the range 10 power 5. Okay, so we cannot use a brute force approach here. That means for every k values we cannot come and check that here. Okay, so we have to find a more suitable approach. Okay, so what we are doing is, we are going to use the heap approach here. Heap, or you can call it as a priority queue. Okay, priority queue. So what we are doing is, first I am going to map elements of nums1 with nums2. Okay, why I am doing that? See, one thing is very clear. I am going to take the minimum of elements. Okay, in nums2. If I can sort nums2 in some way. Okay, such that See, if I sort nums2, then one thing will be very clear. I don't have to find waste time in finding minimum, okay? Because it's sorted, so we will know which is the minimum element in them, okay? That is one thing. Now, one more that difficulty coming here is, see, they are mapped, okay? Every element in this is mapped to the corresponding element in this. If I sort this, I may lose that connection, okay? So what I have to do is, first I have to map the elements of these nums1 with the elements of nums2, then I will try to sort it. Okay, that's what we are doing here. Okay, and then we will come to this. We will use a min heap of size k to select. See, if you don't, if you not understand this, no problem at all. Okay, while implementing, we will understand this. Okay, just read for it yourself. What is this? We'll come back to it later. Okay, so just follow with me. Just be with me. You will definitely get to understand it. Okay, what we are doing is, see, there are many ways to do it. You need not use zip and all these functions like that. Okay, there are simpler ways to do it also. Okay, you can just follow simpler ways. Okay, what we are taking is, say, pairs is going to be a uh, we are going to pair every element of nums1 with every element of nums2. Okay, so a represents the elements in nums1, b represents the same corresponding element and the same index in nums2. Okay, I am going to pair them. Okay, why I'm pairing them? Because I want to sort nums2, but I don't want to lose the connection of each element with nums1. Okay, I am pairing them. Okay, next, what I'm doing is, please pay attention to these things. These are very important things. You may, these things can look, like something very different what's happening here, but these are very easy. So then I'm sorting, I'm passing a key function. What it means is that, see, it's very, very simple. I have to sort each index x. See, you must be knowing that each element in this pairs array is having two elements, a and b. Okay, the a is coming from nums1 and b is coming from nums2. If you can print and show, they will get that. Okay, but I want to sort it based on only the b. Okay, only the factor b. That's okay, only this factor b. Okay, that's what I'm trying to convey in this way. Okay, I want to get the pairs in a descending order based on the values in the second index. Okay, the second index, that means the second element which represents nums2. Okay, I want the sorting only to be happening for elements in nums2. Okay, so this is what it is. Okay, x of 1 means I'm ignoring the x of 0, only the sorting happening based on x of 1. The x of 1 means this b. Okay, this b which comes from nums2. Okay, and we are giving a minus here because, see, normally sorting will happen in ascending order. Okay, smallest first, then the largest will come at the end. Okay, but I want the reverse. I want it in a descending order. Okay, that's what is happening here. Once I've implemented that, we will have something like this. Okay, just pay attention here. See, now nums2 is sorted. Okay, so its elements are in a descending order. That means the first element of nums2 is the biggest one, then the last element of nums2 is the smallest one. We can say that. Okay, what I will do now is, I will fix element in nums2. Okay, for example, this is the ith index I'm fixing. Okay, this is the ith index I'm fixing. Now what will happen is, see, this index is fixed. Okay, now from the elements which left in nums1, okay, these are the elements which left. Okay, these, from among them, I would select k minus 1 biggest numbers. Okay, because, see, what is the final answer going to be? Okay, sum of those numbers into minimum. Okay, minimum is fixed now. What is the other one? Sum. Now I have to try to find a way to maximize that. Okay, that I will do using heap. Okay, one thing you have to notice that the element corresponds. See, this is ith index, right? The corresponding ith element in the num1 should always be included. Okay, that we cannot exclude. That is the only condition. Among the remaining elements in twelve left, we have to select maximum k minus 1 elements. That is, max possible elements k minus 1 times. Okay, k minus 1 max elements. That is the basic idea. Okay, so the minimum element is fixed at nums2 of I. We can pick largest k minus 1 integers from 0 index to I minus 1 index. Okay, this is where I'm going to use min heap. See, min heap means, so what we are, why we are implementing min heap. See, try to understand this. See, as I move further, for example, I am shifting this element to the right. Okay, now what will happen is, this element will get fixed. Okay, so what will happen is, see, I have in my heap the maximum of little elements I. Okay, for, see, from 0 to I. Okay, please try to understand it. The I went to I plus 1. Okay, this element now went to I. This is the next iteration. Okay, it went to I plus 1. Okay, but my heap has the biggest elements from 0 to I. Okay, including I. Okay, so what why I want min heap is because I want to, among, see, I have k elements in my heap now. I want to remove the smallest element possible. That's why I'm choosing min heap. Okay, I will remove the smallest element possible. In place of the smallest element, I will include the ith element. Okay, because the ith element is compulsorily needed in the heap. I cannot remove it. Okay, because the condition of it, because this min is fixed, right? So its index is fixed, and the corresponding index in nums1 has to be taken. So what I will do is, I will first remove in the previous iterations heap. I will remove the smallest element, and then I will include the current element in the heap. Then I will take the sum. Okay, that is the basic idea. Once I show you in the code, you will definitely understand it what we are doing. So till this part is very clear. We are mapping the elements. We are sorting it based on these nums2 element. Okay, that in a descending order. Please remember this thing. We are doing a descending sort. That means the elements are sorted. That means the pairs are sorted in a descending order based on the values of the nums2 corresponding nums2 element. Okay. Now we are going to use a minimum heap to maintain the top k elements. What we are doing is, see, just take a simple list. Okay, this list in Python. Okay, what we are doing is we are taking the first k elements. Please pay attention to each of the words I'm using here. See this. It will take a lot of time to understand this code, but I have gone through that. I have gone through that procedure. I am trying to make this video so that you can understand it as well. Okay, this is just a leap, just a list with the first k elements. Okay, this is the initialization part. The loop has not started here. Okay, it's just the initialization part. Okay, now this is just a variable. Okay, which is having the sum of the first k elements. Okay, don't go by the name. This is not a heap till now. Okay, this is not a heap till now. Okay, it's just a list. Okay, I'm taking the sum now. Okay, now I will use the heapify function to make it as a heap. Okay, now this particular thing is a heap. Okay, this is a list, but elements are sorted in such a way that it will be having the property of a heap. Okay, now comes the answer part. Okay, I am inserting the answer now. Okay, what was the answer? The sum of the first k elements, okay, into the minimum value of the corresponding elements in num2. Okay, that is what is this. Okay, yeah. Remember, as I told you, they are sorted in a descending order. Okay, so when I fix this element, this is going to be the minimum. Okay, so the ith element in this case is the, see, for when we are starting. Okay, we are taking the first elements. Okay, now tell me what will be the index of the first minimum. Okay, it will be k minus 1, because see, when we say first 5 elements, we have to start from 0. Okay, so the last element, that is the kth element, will have index of k minus 1. Okay, that is what is happening here. Okay, that is a kth minus 1 index, and I'm taking the first value of that because I'm one nums2 value. Okay, the zeroth value is for the nums1. Okay, see, this value is for nums1, the first value is for the nums2. Zeroth index is for each pair. Zeroth index is nums1, the first index is nums2. Okay, that is what is the basic idea. This is the insertion part. Okay, this is for the first elements. Now what I will do is I will move this value. Okay, where is it? Yeah, this value. See, this is the minimum fixed now, right? Now I will move it one by one. Okay, this is what will be I. See, it is initially in the k minus 1 position. Please pay attention here. Now it will be in the kth position, and it will keep on moving. Okay, it will keep on moving. Okay, what we are doing is we will remove the smallest element now from the previous k top k elements. Okay, in place of that we will add the element representing this minimum. Okay, that means, for example, this becomes k now in the next iteration. So the corresponding element in num1 will be now included in my heap. That is the basic idea. Okay, this is what it is. Yeah. And then add nums1 of I to the top k elements. Okay, this is what we're doing. See, we are popping out. That means the smallest element from the previous iteration is popped out. That is subtracted from the top k sum. Okay. Now the current ith element. Okay, the current ith element, which is going to be the minimum element. Okay, this is going to be added to this. Okay, remember, we have not added to the heap as of now. Okay, so it will be added in the heap in this way. Okay, I will again repeat. See, what is happening is, see, we have moved one step now. Okay, this iteration has started. What we are doing is, in my previous heap, I am popping out the smallest value. Okay, in place of that, I am going to insert this value. The current, see, I am with my ith index and right? So the ith value should be included. The ith element of nums1 should be included. That's what we are doing here. Okay, now I am including that element in the heap also, right? Now I have to find the answer. Okay, how to find the answer? Top k sum, which I have already updated here. Okay, top k sum is updated here. Take the top k sum. Okay, then multiply it with the corresponding value in the nums2 array in the alpha position. This is what it is. Okay, and this is just the answer. Okay, it's just a score. We have to find the maximum of all such scores. That's why we're doing this. Okay, max of any previous score and the current score. Take it and store it in the answer variable. Okay. Finally, after this loop is completed, we have gone through all possible such cases and finally written the answer. Okay. Yeah, friend, that was all. If you talk about the time complexity, see, in a heap, sorting, like, see, sorting the CPU function which you're seeing here, this itself will take n log n time. Okay, because log n time for adding a single element, and we're doing it for n such elements, so it's going to n log n time. And if you see, yeah, the heap up, heap proofs, these things also. Okay, the heap is of size k. Okay, remember that thing. So it's going to be log k times, but if you compare k and n, obviously n is going to be bigger. So obviously it's going to be n log n only. Okay. So yeah, and that was all. So what the idea here is, we are see, here everything is random. Okay, we don't know how to take the instances. So what we're doing is we are fixing one part. See, the answer has two parts, which you are seeing here. Okay, the answer has two parts. We are trying to fix one part. That is, we are sorting the nums to array so that at least we can iterate over it. Take one element at a time and find the corresponding biggest value in the nums one array. That is the basic idea which we are using here. And for finding the biggest k minus one elements, we are using the min heap. That is the basic idea. So yeah, fine, that was all for today. See, my request to you will be, see, I have spent a lot of time understanding this particular course and explaining you. I might have gone a bit faster, but you have always the option of rewinding the video and playing it in a slower time frame. Okay, in a slower speed. So you can use that approach. And see, you have to be very clear in what we are doing. Okay, for example, see, if you are like wondering what these things are, and see, you need not spend much time in that. Okay, it's just language, program language, and there's just the functions of that. You need not know them. There are other ways to do it also. Okay? I don't like this approach. Basically speaking, I would have taken see, I could do it like, for example, for a comma b. See, no need of doing it. You can just iterate I from 0 to n and take the ith element of both nums1 and nums2. That you can do. Okay, no need to wonder what is happening here. This lambda function, I will definitely advise you to learn this if you have not learned it till now, because you will be using it many times. Okay, this is for getting the descending order of the pairs based on the value of the nums2. Okay, and these are the heap implementations. Okay, I've already told you heap is nothing like that as such in Python. It's just a list, and we are sorting in such a way, in a heapify way. In terms of heapifying it, such that the elements are routed in such a way that it becomes a heap. Okay, and then we are doing the power operations, and then we are pushing it also, the new element, the current element, and yeah, that's it. And we are doing the calculation, finding the max. Okay, yeah, fine. That was all for today. If you have any doubts, please do comment below, and yeah, let us meet tomorrow. Thanks a lot.